All right, ladies and gentlemen. So today's lesson is lesson 2 in our unit 1 transformations. Today's lesson is about reflections. So we're going to talk about some reflections. So a reflection is just that. Let me write this down. Reflection. It's when you flip an object over an imaginary line. Okay. It doesn't change size. It doesn't change congruence. They're still congruent to each other. It's just flipped. It's looking the opposite way. An isometry is something that preserves congruence. And I talked to you guys about this yesterday. We call the first 3 transformations that we look at, we call them rigid transformations. This should be in your notes from yesterday. Remember, a rigid transformation, that's going to be translate, reflect, which is what we're looking at today, and then tomorrow, rotate. Now, there are more transformations, but those 3 are rigid or isometries because they preserve congruence. So this is just saying circle the isometry, circle the transformation of reflection, and make sure that congruence is preserved. So when I look at this image and I compare it to this image, I see that this one is made bigger. So that doesn't mean it preserves congruence. This is not an isometry. When I look at this one, the shapes are congruent. The shapes are congruent. I just changed the way that I'm going to put changed orientation. So I moved it a little bit. I just changed the orientation. So this is an isometry. And then when I look at this little turtle guy, this is also an isometry. They're still congruent to each other. They're the same size. I just reflected it or flipped it over an imaginary line. So the first thing that we're going to do is talk about reflecting. So a reflection is when you take something and flip it over an imaginary line. So if I were to draw the reflected image of each figure, well, let's see. I have to draw the reflected image of this guy right here. So I'm going to start right here with its little, I don't know, eyebrow thing. And then it looks like it's got some hair. And then they kind of join right here to an ear. And it's definitely not going to be perfect. And I'm not in there, but no jokes about my drawing skills, okay? And then let's see, his face kind of droops down like this, and he makes this little whiskery thing. I don't know. Let's see, he's got his chin, his smile, the other half of his nose. He's got a little wrinkle in his nose. He has an eye. And then he has an eyebrow. So not hideously horrible, not perfect, but that's a sketch of a reflected image. So I just want to say that this is reflected over line L. The pre-image is, remember, the original, which would be the gray picture. The image is the new item, which to me is just a white and black outline, right? It's not shaded in like that first one. All right, so now we're going to reflect this triangle over line L, and there's something unique about reflecting. So I'm going to draw a little line here that's perpendicular. Perpendiculars measure distance. So I know that if I'm reflecting over this line, if I'm going to reflect over the line, the distance from each vertice is going to be the same. So I'm just going to eyeball this distance and try to match it up. So then I'm going to measure. It just helps me measure a perpendicular, kind of eyeball a perpendicular, and I'm going to draw one that's, I think, the same, and I'm going to put that point. And then I'm going to do the same thing here. Draw my perpendicular, kind of stretch that. That's a little bit too much, I think. Let's try that a little bit. How about like that? Okay, so now I'm going to connect my points. So not perfect, but let's talk about what happens when you reflect. I'm sorry, you guys know I'm sick. I apologize. You're going to keep hearing me sniffle. When you reflect an object over a line, the distance to the line is the same. Distance to the line is the same. And remember I said that distance is measured in perpendiculars, right? So I just kind of sketch perpendicular lines. I'm just sketching these perpendicular lines. And this measure here should be the same here. This measure of this little green line segment is the same. And this red line segment, they're the same. The distance from the line of reflection for each point is the same. Okay? So that's how you reflect an image. So what is a reflection? A reflection reflects a point so that the line of reflection is the perpendicular bisector of the segment connecting the 2 points. So I'm going to go back up here and I'm going to look at this. So if you think of this line right here, this whole line segment, this is the line segment that connects the 2 points, the pre-image and the image. What it's telling you is that this line of reflection, line L, my line of reflection, is actually the perpendicular bisector of that segment. Let's talk about what bisector means. Bisect means that you cut something in half. That's why the distance or the length of the line segments from the line to the vertice are the same. If a point is on the line of if the point is on the line of reflection, then the point does not move. Okay, if the point is on the line of reflection, the point does not move. And remember that it uses a line like a mirror to reflect a point or a figure, and reflection is an isometry, also called a rigid transformation. That might be a vocabulary word. So what does it mean? Both of them. It means that they preserve, I have to slide up a little bit so I can write. They preserve congruence. Preserves congruence. Okay. Preserves congruence. That's what isometry or rigid transformation is. So suppose that you bounce a cue ball. I don't know if there are any pool players in the room, but suppose you bounce a cue ball off of side A before it rolls into pocket B. Locate point C alongside A that the ball must hit. So what it's saying is you have to pick a point. You have to pick a point somewhere lying across this line. You have to pick a point somewhere so that I'm going to put a big blob right there. I don't want it to be that big. I need it to be a little tiny point. You want to pick a point such that the distance from the cue ball to point C and then the distance from point C to point B are the same. So let's see, that's my first guess. I'm going to guess that point C is there. What if I try moving point C up here? Look at this light pink line. Do those look the same? Or what if I put point C way down here in the corner? Well, the red one is definitely not it. I think that the one that I drew originally is probably your best bet. So I'm going to highlight it in yellow. This is probably the best location of point C because it looks like the distance is about exactly the same. And actually, we can maybe even do one better. Let's erase all these and try again. What if I put point C about right here? So what am I trying to create? Basically an isosceles triangle, right? This looks like it's congruent to that. That's the whole science behind pool. So now you guys can go to the pool shed or pool shop or whatever, the pool house, and play pool for money. No, I'm just joking. So they need to have the same distance. That's what we're looking for. That's what reflection means. So this would be reflected off of this line right here and bounces into that pocket B. We're looking for the same distance. Okay. All right. Let's go on to the next one. So example number 2 gives us a quadrilateral. Quadrilateral JKLM has these vertices below. We're going to graph it and then we're going to reflect it over the line x equals 1. So remember VUX. You learned this in Math 1. So x equals 1 is a vertical line. Down here, we're going to reflect it again over y equals, that's a horizontal line. So the first thing that we're going to do is we're going to graph our image. And I put on the board today things that you need in class. I put notes, binder, pencil, colored pencils, question mark, highlighters, question mark, and then a smile. So you might want to pause at this time and go over to the Student Center and get some colored pencils, or if you have some of your own. And I definitely have some highlighters sitting on the table up front because we were using it in Math 1 and I hadn't put those away yet. So highlighters, colored pencils, something like that. So let's see. J is the ordered pair 2, 3. It's point J. K is the ordered pair 3, 2. Point K. L is the ordered pair 2, negative 1. And M is the ordered pair 0, 1. Okay. Whoops. So this is my pre-image. My pre-image is in blue. Okay. Now I'm going to reflect it. I'm going to reflect over the line x equals 1. So I'm going to draw that line of reflection. It's a vertical line. And I'm drawing my line of reflection in red. And I'm going to identify my new points. So point M is 1 unit away from the line of reflection on the left side. So I'm going to move it 1 unit away on the right side. This is now point M prime. Point J is 1 unit away on the right side. So I'm going to reflect it to the left 1 unit away. That's J prime. K is 2 units away on the right. So I'm going to go 2 units away on the left. And this is now point K prime. And L is 1 unit away on the right. So I need to put it 1 unit away on the left. This is L prime. So L, M, J, K. So this is now my image. I tried coloring that in for you. This is my image. Okay. So that's the first one. The second one, so the image is in green. Okay, so now we're going to do the same thing. Our pre-image is in blue. And we're going to take our pre-image, and now this time we're going to reflect it over y equals negative 2. And I'm going to do that one in purple. I'm going to do that one in purple so you can see it. So the line y equals negative 2 is right down here. I'm taking my blue image, pre-image, my blue pre-image, the one that I originally graphed, and I'm going to reflect it over this line. So I have to figure out how far point J is away from this purple line. So J is 1, 2, 3, 4, 5 units away from the purple line. So I need to go 5 units in the opposite direction. 1, 2, 3, 4. So it's actually going to go off my graph just a bobble. That's going to be J prime. Point K is 1, 2, 3, 4 units away above. So I need to go 4 units below point K prime. L is 1 unit above my reflection line. So now I'm going to move L prime 1 unit below my reflection line. And M is the ordered pair 0, 1. It's right here. And it's 1, 2, 3 units above my reflection line. So I need to put it 1, 2, 3 units below. This is M prime. And now my image looks like this. So if you were to look at all 3 images, pre-image and my 2 images, my 2 reflections, they're all congruent. They all have the same dimensions. It's just that they were moved, reflected. One was reflected over a horizontal line and one was reflected over a vertical line. Okay. Oh, and I just saw this. Let me do this. I really wasn't paying attention. I'm feeling blinded by my brain today. So I'm going to actually take this 2, 3, J, 3, 2, K, 2, -1, L, and 0, 1, M. I didn't realize that there was another graph right there. That's absolutely ridiculous. I'm sorry, you guys. So 1 unit away above, 1 unit below. 1, 2, 3, 4 units above, 4 units below. K prime. 5 units above, 5 units below. J prime. 3 units above, 3 units below. M prime. There you go. So let me erase this so it's not so much on that line. There you go. So I did the vertical one on the first graph, do your horizontal one on the second graph. Okay. All right. Example number 3. Quadrilateral ABCD has vertices, blah, blah, blah. And they're already graphed for us. Thank goodness. So we're reflecting this image over the x-axis. So I'm going to color red the line of reflection. I want to draw your attention to the line of reflection. So we have to figure out how far each vertex is from this line. Well, point A is 1 unit above it, so I'm going to put it 1 unit below. Point B is 2 units above it, so now point B is going to get reflected 2 units below, B prime. Point C is 1 unit below the line of reflection, so I have to reflect it, so it's 1 unit above. And point D is 3 units below. So when I reflect it, point D becomes 3 units above my line of reflection. So A, D, C, B, A. So that is my reflected image. So for this one, I want you to pause your video. I'm going to draw your line of reflection. You're reflecting over the y-axis. And I want you to pause the video and I want you to reflect it. I want you to count the distance each point is away from the line of reflection, and you're going to move it that same distance away from on the other side of the line of reflection. So you're going to reflect that on the other side. Okay, so pause your video and do that. Make sure that you label your points with the primes. Okay, so if you've come back, hopefully you see something like that. Hopefully you got something like this, okay? Example number 4, same quadrilateral, ABCD. We're going to graph the image under the reflection of the line y equals x. So I want to tell you about a rule. So the rule, when you reflect, this is really important, over the x-axis. Let's think about what's happening. When we reflected over the x-axis, which is this example A, we took x comma y and transformed it so that the x number stayed the same and the y value became its opposite. Okay, let's think about the rule for when we reflect over the y-axis, which is right above. When we reflect over the y-axis, so our x comma y transforms such that, so A was originally the ordered pair 1, 1, and now it's -1, 1. So it becomes the opposite of x comma y. So when we reflect over, here's another rule. When you reflect over the line y equals x, when you reflect over the line y equals x, you actually change the order. You change places. X comma y transforms to y comma x. So I have written 3 rules for you. 3 rules for you. So let's do that. Let's go ahead and reflect this over the line y equals x. So I'm going to show you what that line looks like. This is the line y equals x. Right here. When x is 1, y is 1. When x is 2, y is 2. When x is 3, y is 3, so on and so forth. So if I wanted to reflect point A, well, point A is on the line, right? So it doesn't move. So A prime is going to stay right where it is. Point B is the ordered pair 3, 2. So when I reflect it, it becomes the ordered pair 2, 3. Point C is the ordered pair 1, 2, 3, 4, negative 1. So when I reflect it, it's going to become the ordered pair negative 1, positive 4. Maybe I should write these off to the side. A prime. Change the x and the y to y comes first. 1, 1. Doesn't move. B prime. Changing my x and my y. So instead of 3, 2, it's going to become the ordered pair 2, 3. C prime. Instead of the ordered pair 4, negative 1, it's going to be the ordered pair negative 1, comma 4. And D prime, remember I'm just changing the order. X, comma y. I write it as y, comma x. Negative 3, comma 2. So C prime is at negative 1, 4, and D prime is at negative 3, 2. So my reflected image looks like this. So what if you have to reflect over, let's talk about, this is a special one. I think you have it in your homework, definitely on a Delta Math. What if you reflect over the line y equals negative x? Let's see, if you reflect over the line y equals x, you change the order. If you reflect over the line y equals negative x, what do you think you do? Well, the rule is, hopefully you're guessing, you change the order and the sign. So it becomes opposite y, opposite x. That's the reflection rule. So we have some opportunity here to write our rules. Remember, this is in function notation. So if I reflect over the x, the rule is x comma y transforms, reflecting over the x, x comma opposite y. If I reflect over the y-axis, x comma y transforms opposite x, y. Have a sneeze. Excuse me. The last one, if you reflect over the line y equals x, x comma y transforms into y comma x. And don't forget our special one. If you reflect over the line y equals negative x, it transforms x comma y such that opposite y, opposite x. So I think those are important. I had a conversation with a student last night about, once we get to about right here and we start talking about all these rules, you guys are shutting me out. You're like, what is happening? So I want you to remember what you're doing. So I'm going to tell you the rule, but really I just want you to know what you're doing. If you are reflecting a point over the x-axis, you're just changing where the point lies. It's going to lie on the opposite side of the line of reflection. So if this point is 3 units above the line of reflection, when I reflect it, it's going to be 3 units below. Okay. What about if I reflect over the y? Oh, sorry. Reflect over the y-axis. It's a squiggly, messy line. I'm going to put point B right here. Well, point B is 1, 2, 3, 4 units away. So I'm going to put point B 4 units away on the opposite side of the line of reflection. I'm changing the side where it lays on. You're flipping it, right? I'm going to draw my line. This is going to be the line y equals x. So if I have the point 3, 0, when I reflect it, it becomes the point 0, 3. A prime. I'm going to show you what the line y equals negative x looks like. That just means you have a negative slope of 1, right? So if I had the point 0, negative 4, and I reflected it over this line, I called this B, I'm going to go in the opposite direction, right? So that would be right here at 4, 0. Okay. So that's it for your reflections. That's your whole lesson on reflections. So your homework for today is lesson 2, homework reflections. There are a total of 12 questions. It's the next 2 pages in your note packet. Lesson 2, homework reflections. And I'm going to go back to our module so we can see where we are, possibly. So today is Wednesday. So I'm going to put our video lesson right here. Reflections, 1.2 reflections. You have a reflections activity in Desmos. When you click this, it will take you right into my Desmos class. This activity is 5 points. We were going to do a card sort together in class today, and since I'm not going to be here, so this is going to be worth 5 points. It needs to be done today in class. This is an in-class activity. Don't finish it by 3 o'clock, I'm going to know that you didn't do it in class, and I'm not going to give you the points for it. Okay? This is an in-class activity. Then I'm going to embed our video that we're doing right now here. You have your homework, which is pages 7 and 8 if you numbered your pages. And then you have a quiz is. It's a quizzes assignment. This link will take you right there. Remember that if you did not join my quizzes class, last week, you're not going to be able to join it. So I'm going to go back to my modules. I'm going to go to last week's module and snag the join code, because I know a lot of you guys did not join my class. I think I only have 4 of you in there. So I'm going to edit. I need to copy this, the join code for quizzes. I need to put it in here. You've got to make sure that you do the quizzes. Now, that's not due till Monday, but you have plenty of time. Your video is probably going to end up being 40 minutes just because I'm walking you through the whole module, making sure that you know what you're doing. So again, if you did not join my quizzes class, and I think there are only 4 of you that did, you're going to have to join the quizzes class first, because this assignment, this 1.1 transformation, is assigned to the Math 2 quizzes class. So you have to join the class first, and then you'll see 1.1 transformations. All right. We'll go through your 1.1 translating homework tomorrow. I'm not going to have to worry about that. You're going to need some earbuds, and you